I am here to do work again, and today's work shall be about classifying polynomials, sum and difference of cubes, and factorizing by grouping. And we will maintain the standards that we have set so far, which is that we check every single answer after trying to solve the problem, of course. Okay. We are hold on. Yes, we're ready. Okay. Name each polynomial by degree and number of terms. All right, this is a linear polynomial and it's got one term, so it's a monomial. So I would say it's a linear monomial. This is of degree 4 and it has two terms, so I would say it's a binomial of degree 4. Or a quartic binomial. This is just a constant term, and it's a polynomial of either degree 0 or degree infinity. I've heard both, but we can just say it's a constant monomial. This is of degree 6, and it has 5 terms. So of degree 6 with 5 terms. That would be its unambiguous sort of name. There it goes monomial for a one-term expression, binomial for a two-term expression, trinomial for a three-term expression, and then it doesn't go on like that. Although it would make sense to have like quadrinomial and pentanomial, for example, but it just doesn't. As for degree 1, 2, 3, 4, 5, etc., etc. Okay, so at the very base, you get a constant. Then of degree 1, you have a linear. Degree 2 is a quadratic. Degree 3 a cubic. Degree 4 a quartic. Degree 5 a quintic. And beyond that, the names are rarer. But I suppose this one could be called a sextic. But anyway, moving on. Okay, so this is a cubic with 4 terms. A quadratic trinomial. A linear monomial. And a cubic trinomial. Right, let's just make sure that they haven't done this with any of the others. Okay, doesn't appear so. Right. Then why is it impossible to have a linear trinomial with one variable? A linear trinomial with one variable. If it's linear, one variable. Then the terms will be of the form ax to the 0 or bx to the 1. And if there's 3, it being a trinomial, look like okay, I better use a different letter in front. C to stand for the coefficient. Yeah. It'll either look like this. Or both reduced, both simplifiable to a binomial. So you can't have a trinomial that is linear. Okay, simplify each expression. There is one m to the 4 terms. So no, sorry, there is 2 m to the 4 terms. Careful now. So put them together, 5m to the 4. Put the squared terms or put the m squared or the quadratic terms together. So 4m squared. Over here, x to the 4 takes 3x to the 4, so negative 2x to the 4. And then we have a 9x there. Down here, 7x cubed, and combine the quadratic terms. So 3x squared adds 6x squared, so 9x squared. Linear terms next, 5x, just 5x by itself. And finally, constants. 5 and negative 12 makes negative 7. Here, fifth power first, 12x to the 5. Cube terms next, x cubed terms next. 8x cubed, take 7x cubed, so that is a single x cubed. 3x squared at 6x squared, okay, 9x squared. Okay, and finally 4. Now check everything. Okay, full agreement, constant monomial, polynomial, 6th-degree polynomial with 5 terms, equivalent name, cubic polynomial with 4 terms. Yep, completely equivalent. My argument was more thorough, better, actually, than their answer. That's true. That's true. And that's true. Okay, first page, completely correct. Next. Okay, m to the 4 terms first. So we'll make use of colors here. M to the 4, n to the 2 terms next. There's only one. Constants, there and there. And finally, that term there. So I'm going to put them in order. I'm going to put the term with the highest degree first. What does that mean? Highest degree? What's the degree of each term? Add up the powers of all the variables. So this is of degree 6. Okay, so m to the 4 n squared is first. Then this term here being of degree 5 will be next. So plus 13m squared n cubed is next. Then the m to the 4 terms collect and gather. That'll be 11m to the 4. Take 5m to the 4, so that'll be 6m to the 4. Done, done, and done. 2 and 2 and 4. Great. Now here, mn cubed, mn cubed, mn cubed. Okay, got it. Okay, highest degree first. So we see that's of degree 4, and so is that of degree 4. So I like to put the ones of one variable first. So negative 4n to the 4 plus 2n to the 4, so negative 2n to the 4. Done, done. Then negative 10, positive 7, negative 6. So negative 3, negative 9. So it becomes negative 9. Okay. Done, done, done. And then here, negative 6n cubed. So negative 11n cubed. All right. Now find each. You know what? I'm going to check these as I go. Save scrolling a little bit. Okay, and they even put it in the order that I chose. They did not put that one in the order that I chose, and I wonder why. I wonder what would be a canonical order for a polynomial. But anyway, now we are to find each product. Okay, it's here. Here, simply apply FOIL. So 2n squared, add 3n, take 4n, so negative n minus 6. 20v squared plus 11v, take 3. Negative 2r squared minus 12r plus 14. 9x squared minus 3x minus 30. Okay, just multiply through by negative 4x squared. Negative 16x to the 4 plus 24x cubed plus 8x squared. Next, multiply through by negative 5x. So negative 20x cubed plus 30x squared plus 10x. Now multiply through by negative 1. So negative 4x squared plus 6x plus 2. And sum. Okay. Conveniently, by doing it in this format, it's already in order going from left to right. It's just sort of like, you know, column addition. There would just be zeros in these spots here. So we say negative 16x to the 4 plus, hold on, be careful. Have to combine these together. So plus 4x cubed. And then here, 34x squared. And here, 16x. And here, 2. Next, pretty much exactly the same format, so do it better and faster. Negative x to the 4 plus 3x cubed. Take 5x squared. That's having multiplied everything by x squared. Now to multiply everything by negative 2x. Okay, that should be 2x cubed. Then negative 6x squared. Then positive 10x. Now everything through by negative 8. So this should be 8x squared. Take 24x plus 40 and add just like a chimney sum. Negative x to the 4. Combine these. Plus 5x cubed. Combine these. What's 8? Take 11. Negative 3. And combine these. 10 take 24. Well, that's negative 14. And finished. Next up, these binomials here. Okay, just apply FOIL. So 24m squared plus 24mn plus 24nm. No, do it the right way around. mn. That's in alphabetical order. That helps you simplify and collect like terms. Next, plus 24n squared. And of course, this simplifies to 24m squared plus 48mn plus 24n squared. Here we have pretty much the same pattern. Okay, so 48uv. That's 24 in the middle. That's 48 on the outside. Add them together and you get 72. Wait, that's a mistake. That should be u squared. (72uv) and then plus 24v squared. Okay, critical thinking. Simplify this. I don't know what that means by critical thinking, but here we go. AC plus AD plus BC plus BD. Simplify and then classify by degree and number of terms. Sure, 2x plus 12x cubed. Take 15x squared. Now, in order, in descending powers of x, 12x cubed, take 15x squared plus 2x. So this is a cubic with 3 terms, so a trinomial. Cubic trinomial. And now to check. Agreement. Good. True. Yes. Yep. Good. Mm-hmm. Yep. Okay. Everything was handled successfully. Okay, a sum and a difference of cubes will come next. But what is there to understand about this? What is there to know in order to do this successfully? Some identities. Difference of two squares. We'll build on what we know. AKA dots, follows the following pattern. There are my two squares. That's the square of x, that's the square of y, and of course this is a difference of two squares because I'm minusing one from the other. And here's the pattern. X take y times x plus y. If you just expand that out, you get x squared take xy, add xy, take y squared. Cancel the two middle terms, you get the x squared y take y squared. A difference of two cubes is an identity to be learned. X take y times x squared add xy add y squared. And we also have the sum of two cubes, which goes x cubed add y cubed is identical to x add y times x squared take xy add y squared. Hold on now. Don't just take the formulas as what they are. Convince yourself. That's the power of mathematics. You can actually convince yourself of these things. For the first one, we prove just simply by expansion. So it's x take y times x squared add xy add y squared. First, multiply everything through by x. So it's x cubed add x squared y add x y squared. Next, multiply everything through by negative y, but put things in alphabetical order. So, negative x squared y, negative xy squared, negative y cubed. Who cancels? These cancel, and these cancel, and thus x cubed take y cubed is the truth. Now, how about the other one? First, multiply through by x. So, x cubed take x squared y plus xy squared. Next, multiply everything through by y. X squared y take xy squared plus y cubed. What cancels? Negative x squared y and positive x squared y cancel. Xy squared and negative xy squared cancel. And so we recover the x cubed and y cubed. Now to put them in action. And this is 24 questions in a row, so we shall handle them 6 at a time and check 6 at a time to make sure that we're doing it right. So this here is a sum of two cubes. It's the sum of the cube of x and the cube of 5. So following the pattern, we have x add 5 times x squared. Take xy, so take 5, so take x times 5, so 5x, plus y squared, so plus 25. This is the sum of two cubes. It's the sum of the cube of a and the sum of the cube of 4. So following the pattern, I write a add 4, then a squared, take 4a plus 16. The difference of two cubes, x cubed takes x cubed and 4 cubed. Following the pattern, x take 4 times x squared and 4x takes 16. No, plus 16. That's the correct one. The sum of two cubes, the cube of u and the cube of 2. So I write u plus 2, u squared, take 2u plus 4. The difference of two cubes. So I write x take 3, open brackets, x squared plus 9x plus wrong plus 3x plus 9. Wake up. Here, the difference of two cubes, 5 cubed and x cubed. Just follow the pattern. Starts out with x take y, so just put in 5 take x. Then it opens up x squared, so put in 25, and xy, so put in 5x, and y squared, so put in x squared. Right, now to check the first 6. First one, correct. Second one, correct. Third one, correct. Fourth one, correct. Fifth one, correct. Sixth one, correct. And continue. The difference of two cubes, the cube of 1 and the cube of a. So, following the pattern, 1 take a, open brackets, 1 squared, which is 1, plus 1a, which is just a, plus a squared. 1 add a squared times 1 take a. All right. Sum of two cubes next. The cube of A and the cube of 5 by the pattern A plus 5. Then here it's getting harder now, so concentrate. Okay, it's the cube of 2x and the cube of 3. So 2x is 3, 4x squared. This is believe it or not, okay. Done. Now to check. That's right. That's right. That's correct. That's correct. Next. Nope, you got that one wrong. Try it again. And this one. Okay, they've obviously done it in a different order, but this one, try again. Okay. Wrong. Okay, check. 4x. No, still wrong. You're not getting this. Okay, it's a minor error, but it's important. This is not just all plus, minus. And this should not be 4x. Don't know where the hell this is doubling is coming from. No, do the whole thing again. Get it right. Okay, so it's the cube of 2x and the cube of 3. Therefore, I open up with 2x, add 3. Next, I open up here with the square of 2x, which is 4x squared. Then my minus sign, then my plus sign, to make sure that I get the signs right. Here would be the first term by the second term. So it's 2x times 3, which is 6x. And then the square of the second one, which is 9. And check. Correct. That's better. Okay. Another 6. Just got to take a sip of water. Right, so this is the cube of negative a, and this is, of course, the cube of 2. Difference of two cubes. What is the pattern of x cubed take y cubed? It is x take y all times, x squared add xy add y squared. So just input x take y, so minus a take 2, just like that. And then there, like that. Okay, so who's here? Minus a minus 2. That's clear. Who's here? A squared. Take 2a, add 4. Okay. This, no. We need to factor out the 2. Factor out 2x, in fact. And then what we see here is 125x cubed, add 64. And that is the cube of 5x. And that is the cube of 4. And what is the pattern for the sum of two cubes? Let's say x cubed add y cubed. It is x add y all times, x squared, take xy, add y squared. But do it mentally. It's better practice that way. So 5x add 4 in the first simple bracket. Won't get that one wrong. Minus and plus. Make sure that you don't cause a fuss. Here is x squared, so the square of that rather, say 25x squared. Then that times that, which is 20x. Then that squared, which is 16. Okay. All right. What to factor out here? Three. 3a. That's 216 when thirded. So that is the cube of 6. That is 343, which is the cube of 7. So 7a. That's what's being cubed there. And now, to follow the pattern, 3a comes first. 6 add 7a comes next. Open your brackets. Put a minus sign there and a plus sign there. Okay. 36 comes first. Then the 6 times the 7a, so 42a. And then finally, 49a squared. Okay. Here's the cube of 2a. And here's the cube of 5. Now, get it right. 2a add 5 is there. Okay, square that, square the first one. Square the last one. And multiply them together. This is the cube of 4x, and that's the cube of 1. Sum of two cubes. So who's first? Square of the first one. Square of the last one. Product of the two. Okay, and check. Agreed. Agreed. Yep. Yep. Mm-hmm. Mm-hmm. Last 6 here. Okay. This is the sum of two. It's the sum of two cubes. It's the sum of 7m all cubed. Well, it's the sum of the cube of 7m and the cube of 4n. So following the pattern, 7m add 4n. Open your brackets. Square the first one. Minus the product of the two. Plus square the last one. And here, it's the cube of m and the cube of 2n. So following the pattern, m add 2n, square the first one, minus Product of these two. Square of the last one. Good. This is a cube of the cube of A and the cube of 7B. Follow the pattern. A plus 7B. Open up. Square of the first one minus 7AB plus square of the last one. There. This is the difference of two cubes. It's the difference of the cube of x and the cube of 6y. So follow the pattern. X takes 6y. Open up. Square of the first one. Product of the two inners. Square of the last one. Here, factor out 3. Actually, factor out 3y. And what do we get? Well, we get 343. X cubed. We can do that all in one step. Come on. So it's the cube of 7x. It's the cube of 2y. Three y. Now, sum of two cubes. So 7x at 2y. Open brackets. Square of the first one. Product of the inners, but take it away. Square of the last. Last one. The cube of m. And the cube of 4n. So, open brackets here. M at 4n. Square the first one. Take away 4mn. Square the last one. There. Check if that's right. Okay, 19 is correct. 20 is correct. 21 is correct. 22 is correct. 23 is correct. 24 is correct. All right. I think I've got the hang of this one. Now, factoring by grouping. Confession time. I don't actually have much experience with this. I've vaguely heard of it. I've read a few explanations, but I've never really practiced it. First time for everything, though. Let's see if I can do it. All right, so we have 20 problems to try. Okay, so I believe that it sort of goes like this. So I believe that we find it, please. I believe we factor out 3a from the first two terms. So we would end up with 4a squared. Take. Is that right? No, I believe we factor out, we go as far as we can with the first two terms. So 3a squared. Then 4a, we get 4a, take 3. And that looks remarkably like the last two terms, does it not? In fact, the last two terms are clearly just one copy of that. So we get 3a squared add 1 all times 4a take 3. And I must check it after the first two, just to see if I'm actually understanding any of this at all. Okay, so for this one here, I believe you can factor out p squared to get 2p at 5 there. And for the last two, you can factor out 3 to get 2p at 5. And then all together, that becomes p squared at 3 times 2p at 5. Now, was that correct? Yes, it was. Okay, wonderful. Okay, let's go with this then. All right, so we'll check after four more done. After question 6 is finished. Okay. So n squared, and then 3n take 4 plus 3 times 3n take 4. So I believe it just becomes n squared add 3 all times 3n take 4. Next, 4n squared, 3n add 1 plus 1 lot of 3n add 1. So this becomes 4n squared add 1 times 3n add 1. Next, m squared add 2 times m take 1. Next, it's obviously 8. So let's do minus 8. All right, and now here. All right, okay, so everything is divisible by 3. Okay. What a complicated looking thing. Not that complicated. No, they're not all divisible by 3. That's false. Okay. 224 and 56. Okay, 56. I think it's just 50, literally just 56. Oh, yes, that's quadruple. Okay. 56 outside. 56A, thank you very much. And then we're going to have 4Z plus C. And then take away 21Y. How about that? Check. Okay, so well, check 3 and 4. Correct. Yes. Oh, right. Okay, fine. You could have gone a little bit further there and taken out the 7. And that's all good. So it's looking good so far. Okay, next 4. Well, perhaps if you're an infant and you need all the terms next to each other, would you like that? No. Scramble them up. I'll have them in that order, thank you. And then I'll factor out 5h squared from these two to turn that into 5n and turn that one into minus m, just like that. Okay. Clearly this is going to turn into 5n minus m, but only if you factor out negative z. Good. Next. Get the y's next to each other. So 12xy, take 15y. Next. Well, okay, for this one we can factor out 10x. But this one, okay, just try it this way. Probably it's in the wrong order. Now for this one, 25. Okay, that's sufficient. And do not forget, yes. Okay, so 10x take 25, so factor out 5, why not? You could have gone further than this. 3, in fact. Yes. Because that should be a 5. Okay, check these. Okay, so they're the other way around. It doesn't matter. Oh man, I could have gone further here. Taking out 3. Of course. Two more. Give me 2 more sets. Oh my goodness. Okay. What goes into 72 and 192? 8. First one is 8 times 24. And the next one is 8 times 9. Well, okay, that means 24 goes into both of them then. And the first one is, yeah, I mean, the first one's 24 times 8. And the next one's 24 times 3. So 24x squared, please. Take that out. There, like that. Now, our goal is to have 8y add 3x. It's going to be a minus. And it will be 3rx. And we clearly see a common factor of 3. So do not forget this time. In fact, we actually see a common factor of 3x. So do 3x like that. Do 8x minus a single r like that. And do 8y plus 3x like that. Here, HCF of 90 and 36. Well, 18. So Check. Correct. And this. Correct. And this. Correct. And this. What the hell? Did I not even finish? What? Beg your pardon. Must have been like a sort of a brain blip. There we go. Right, okay, fine. Last 4 now. Last 4. I didn't hear a bell. Okay. Put those together. 8 xyd. Take 8 xyc plus 16 x squared c. Take 16 x squared d. And we factor by grouping now. So you can clearly see a common factor of 8xy. An interior, d takes c. And then 16x squared. Negative 16x squared. In fact, put those two the other way around. Okay. Oh my goodness me, look at this. Okay, put them there. Okay. Right, I'm going to see how far I can take these two, and then I'll worry about the other middle ones just at the end. Just give me a sec. All right, then I believe it's that one first, and this one next. And so, if my goal is to get 6m take n, and then I will go even further. And this one. Goodness me, I do not know for this one. Just try things. Okay, 15. 15v. I believe it's 15xv rather. And who goes in the brackets? 7u plus 4. Okay, here I can see that this is wrong. This is clearly wrong. That's not going to work. In brackets I'll have u and then v squared, and that's just not going to work. So it's fine to try, but when you see a failure, try again, but with different. Okay, think about the v squared. Think about that. Well, v squared there, v and v there. So think about it logically. Factor out a single v. Yeah. Now I'll have that v squared will turn into like a v. Come on, think it through. Just divide everything through by 5 first. Just do that. (21xuv) plus 12xv take 14xu take 18xv squared. Now we have a common factor of 3, 3, and 3 on the first, second, and third, first, second, and fourth terms on the terms in the bracket. Yes, I see it. 21xuv take 18xv squared plus, no, minus 14xu plus 12xv. Now 5, open your brackets. Okay, so who's going to be outside the brackets? That will be 3 x v. Who's inside? 7u take 6v and then we get oh yes, okay, all right. Oh well, Common factor of 2. Take that out first. Now, okay. 17 is correct, but the sign is fine. It's fine. It's fine. Yes. Oh man, there's a common factor of x there. Of course there is. Darn it. Super close though. Here. That was correct. Awesome. Brilliant. Okay. Take a small break here. Thank you.